Hey, what's going on, guys? In this video we are going to see how to do linear fitting in C++ programming. But before we go for the programming part, let's go ahead and see the concept behind this equation and stuff. The first thing is, when we have set of data points in a graph and if we try to draw a line that connect to all these points, it's not possible because if you look at these points, these are not aligned straightly, right? So in order to do this one, the mathematician invented a way that will create that will find the best fit line, and in that line, that's gonna give us the minimum error. Like if you calculate the standard error for this one, that's gonna give us the minimum error, and that's gonna be the best fit line for these points, right? And the distance from the point of view of all points is going to be very shorter compared to any other line can be drawn, right? So that's what linear fitting means. Now we are going to see how to create the equation for this one. Like this is the equation we had to use in order to find this best fit line. Now we are going to see how to create this equation in C++ programming. Now here, that's what we are doing right here. So first we introduce this I, j, k, and variables, and after that we ask the users to enter the number of data to be entered in. For example, if the user entered 4, that's going to be stored in here. This array is going to have this 4. This means 4 index we are going to have. And also after that, this program is going to ask the user to enter the x-axis values. So since we enter 4, if we enter 4, the user is going to enter 4x values, and that's why we create this for loop. So the index is going to go from 0 to n, less than n, because 0, 1, 2, 3, it's already 4, right? If it's 4, 0, 1, 2, 3, it's already 4. So that's why it's less than 4, so it's already 4. And then the user is going to enter the x values, and then y values, it's the same thing. And in order to do this one, we have to introduce these things. X sum, this means sigma x square, sigma y, sigma xy. If you look at our equation, sigma y, sigma x square, sigma x, sigma xy. We need all of these 4 things in order to do this problem. Okay. Now let's look at the next part. Now we are using for loop, and then we are storing these things: sigma x, sigma y, sigma x square, sigma xy. After that, we are using this equation, this same equation. Here, if you look at this equation, y is equal to beta naught beta 1 x. Here, beta 1 is our slope. So to find the slope, we have to use this equation. That's n times sigma xy minus sigma x times sigma y, n minus x square, n sigma x square minus sigma x square. Same thing we did here. N times sigma xy, n times sigma xy, sigma x times sigma y, sigma x times sigma y. Okay, over, or to put over, we put slash right here, and n times sigma x square, sigma x times sigma x. Here we have sigma x square. Now here, if you multiply sigma x times sigma x, the same thing, right? Sigma x square. So that's what we did for the slope, and to find the intercept, we had to use this equation, the top equation. That's what we did right here. Okay. Then we have used this one to create this equation. Y fit is equal to this one, right? Now let's go ahead and see some example to see whether this code works. Okay, now I'm running this one, and it's asking the user to enter the number of data pairs to be entered. So let's I'm going to try this one. I have some data. I'm going to try this one and see what I get. Okay, so first let's go ahead and put these values. So this is 50, 70, 100, 120. So we have four data, 4 pairs of data. So this is going to be 4 right here, and let's plug the numbers. This is going to be 50, 70, 100, 120, 50, 70, 100, and 120. Okay, 120. These are our x values. Now let's look at our y values. 12, 15, 21, 25. 12, 15, 21, 25. Okay, now we entered all the values, and if you look at this one, we have the equation that best fit all the points. Now if you wonder what is this one means, this is basically after we find the best fit line, what is this doing is this is just plugging this x value for this one, right, and finding the new fitted lines, fitted y values. That's why we just write here this equation right here, the y fit, and this programming is for this one to find this one. Okay, now let's see whether this equation is correct. We can use this Excel to find out that one. Let's go ahead and select this one and go to insert and select this graphing right here and this one, and if you click this point and select add trend line, and then display the equation on chart. Okay, and let's make this one a little bit bigger. Okay, if you look at the equation, we have 0.817931, 0.1879, and 2.27586. So this is matching with this one, right? And that means this is correct. And let's look at this one. Here we have a temperature resistance equation, curve equation. Now let's try this one too. Now again I'm going to run this one again, and let's look at the data numbers. Set of data is 1, 2, 3, 4, 5. So we have to enter 5 set of pairs, and here x values, the first one is 20.5, 32.7, 51, 20.5, 32.7, 51, and then after that we have 73.2, 95.7, 73.2, 95.7, and these are our x values. Now let's go ahead and type our y values. 765, 826, 873, 765, and then we have 826, 873, 826, 873. After that we have 942, 1032, 942, 1032, and let's enter. And here we have the equation that best fit for this one, and we have, this is replugging the x values. This is our entered x value, entered y value, and we have the equation that best fit for this one. And after we found out this one, this is plugging this x values in this equation and finding the best fit y values, right? And that's what it's doing right here. Now let's also make sure from our Excel thing. Okay, let's go to insert and then go to this graph, click this one, click the points, right click, and then add trend line, display the equation, and you see okay. Now okay, let's make this one a little bit smaller. Now you can see 3.39487, 3.3949, so it's rounded it, and then we have 702.172, 702.17. So this is matching this one. So that's how we do the linear fitting in C++ programming. I hope this helps. Thanks for watching.